this as well. And now we're going to get to the fun stuff. So viewer, right? So we'll do levels /1 that Lua. Because Lua is a data format and it is a programming language. So, or how about this? Levels /test map.lua. And the Lua LSP is broken, by the way. I don't know how to fix it, but so now I have to start to think about isometric maps, right? So let's go to my trusty graphics editor and let's make our tiles, isometric tiles, let's say this big, okay? So let's make our sample cube. Okay. Doesn't need to be perfect. Just for testing. Okay. Well, I don't like how this one line is off. There. All right. Shade it just a bit here. All right. Why not give it a front line too? Why not? That is a cube. Don't like the outline color here. More subtle. That's all right. So now game dev stream symmetric funnel levels test tiles.png. Here we go. Cool. All right. The viewer is going to require we'll do this. Okay. We'll do load level path. Okay. And what's it gonna do? Oh, well, we have some Lisp magic here now. This is the mode I'm in, the power infer. But we'll do require concatenate levels / okay, how about this? Load level name. Yep, levels / name / map. Neat. And what am I going to set this to? We'll go set we need a variable var map. Just call it a map. And it'll be empty. It'll start as empty. Set map. You require map. and var. There's a lot of ways I can manage the sheets. So right now I'm going to do one that's kind of stupid looking. We're just going to call it the one tile. Okay. So set the map to this and set the tile to new image. What did I call this? Sheet? Sheet.png? Tiles.png? Okay. Call it tile set. How about? Tile graphics. Tile GFX. How about? New image. Do this. It's because I don't like. I don't know. Maybe. Graphics, new image. Tiles. Just hard coding it for now. Right? Okay. Now. Draw tile graphics at 0, 0. Okay, not seeing it, but is it actually in fact loading scene/viewer.fnl? Let's make sure of it by changing the color to blue. It's not in fact loading it. Okay, good to know. Good to know. So what is it actually loading then? Oh, because this is actually. Yep. All right. Do dired. Yeah, I shouldn't have had to make a folder. Yeah, makes sense. Oh. Rename to source viewer scene.fnl. There. Now, actually, yep, because I did the dirt rename, actually moved it in the editor. See, Emacs is not that stupid after all. And now we have other thing. Expected name and value. Okay. Set them both to nil. How about that? Module levels/test. Not found. Okay. I'm not going to make my maps in Fennel. I'm going to make them in Lua. But what is... Okay. Module levels/test. Not found. So, isn't it finding... All right. maybe this whole thing is a bad idea. Okay. Name levels / name map. Levels name, yeah. Okay, module levels / test not found. Oh, it's right here. Here's the problem. Alright. Bad argument 1. Drawable expected something or other else. Oh, drawable expected got nil. Right. So we have to do load level. Right. Test. Okay. All right. Minor issue here. Here we go. Didn't set it to background, which makes it transparent. Okay. Good. Now I'm gonna get that eye searing blue out of here. Okay. And yeah, so here we have an isometric tile on the screen. Now, I'm going to think a little bit about a few different things here. The two things I want to think about, let me get a piece of graph paper, because it always helps me out when I'm thinking. And a nice mechanical pencil, because I like that erasability. I like to get a non-erasable. So the map is going to have, it's going to be a 3D map, right? So it's going to have layers, right? So layers, triple nested table, but not really. So the first thing is we're going to do map width, and I think, yeah, we'll do the map width and height, and we'll just include a bunch of numbers, and every number represents a tile. Is that a good idea? Is that good? I don't know. I think it's good. I want to be able to put metadata in there too, though. So it's a lot of data. All right. Start simple. Start stupid. Let's just draw one layer of tiles. All right. Just one layer. So well, I don't need to do this yet, actually, but do this. So we have our the actual map is going to equal a little pattern. All right. So we're going to draw okay. Good. A glider. All right. So width is 3, height is 3, And the map is going to be 1, 0, 1, 0, 1, 1, 0, 1, 0. Okay. So that is our glider shape. Very simple. Right. So now we do this. Draw layer. Index. Okay. Which will be called here. How will we call it? I think draw layer. Let's call this layer 1 because it's Lua. Okay. I think having each layer be its own table makes sense actually. So we can do layers like that because of the nature of things. This is going to be nicer because I can add metadata to each layer, and we're going to go within the layer tiles equals. Okay, like that. You know what? I don't like this system at all, and I'm going to change it eventually because I actually want to use an object editing system where you have objects, each object has like different dimensions, that kind of thing, and then the objects will be rendered into tiles, right? So rather than just storing tiles directly, I'm going to have, you know, an object system. But let's just start simple here. So I've hard-coded the tiles. We're going to draw layer 1, and the way we do this is first we get the layer itself. So we go let layer equal to map we get map layers index tiles. Let tiles. How about? So again, we're going extra simple. And then you go for I from 1 to map width. We'll do. So this is where I need to think a little bit about coordinate systems. So the way that I think is most intuitive is to have the bottom right corner of this as specified actually represent the middle bottom corner isometrically, right? So we've got this map should render. So this map should render like so, right? And we're going to name the coordinates also. I'm going to go with X and Z. And the Y coordinate will be the height. Okay? So we want to go from a certain we want to do this a certain way actually. So the X coordinate, right? So we'll do it in strips of Z, okay? So strips of Z, And instead of width and height, because that's confusing, we'll call it X size and Z size. There. All right. So, 1 to the Z size. For X from 1 to the X size. Except if this is supposed to be the frontmost part of the map, it should be drawn last. Okay, yep. So that's the right drawing order. And very nice. We'll do a draw here. So first, let tile is equal to tiles sum of Z times the Z size and X to get the index, right? Though the Z then should go from here to here because we don't want the map to start at Z size. We want it to start at 0. Right. Okay, so that's 0 index, that's 1 indexed. The tile is the index of Z times the Z size plus X. Okay. And now we can just do this. Draw. For now, we're keeping it really simple. So we'll do when the tile is 1, draw the tile at a position. So another thing, tile pose as the we want to do isometric to screen position. So ISO to screen X index Z. Good. And we'll do this actually. Screen X, screen X, screen Y. Now for Fennel destructuring, there's a way of doing this. So, all right. The reference in the tutorial kind of have some overlap and they have some parts that are in neither, so I just open both of them and I go destructuring. Oh, the ampersand character is allowed in symbols. Didn't know that. So, you can capture the remainder of the table in the local by using ampersand. I didn't know all that. Since when? Very cool. Anyway, we want to do table destructuring. I'm not seeing it, but it should be under let, right? There we go. Okay. Okay. So this is the key you're getting it from. This is the key that it's giving. Okay, cool. So we do Actually, you can just do this. I'm overthinking it. We don't need to name them at all, right? Cool. And the only remaining thing is, I'm going to put this here. One thing about Fennel that is annoying to me is there's no like hoisting, so you do have to like actually put things in the order that they're used rather than the like best order to read things in. Definitely a bit annoying. So, ISO to screen X, Z, X, Y, Z. Okay. Now, let's go back to our cube, right? So, we know that the X coordinate is this edge of the cube, and the Z coordinate is this edge of the cube, and the Y coordinate is this one, right? So, we have to do this. Values, okay, here's the X. X is going to be think about this. So we'll go with tile space coordinates, where 1 represents 1 tile over. I think that works. So we have tile size, right? Okay, we're just gonna start simple. Start simple and just build concepts. So ISO to screen. The X coordinate is going to be literally just the Z coordinate minus the X coordinate. Okay. And the Y coordinate is going to be the sum of Y and it's going to be the sum of Y and 1/2 of X plus Z. Yep. All right. That was simple enough. Y plus X. Okay. All right. So now we're going to test it. It should fail with some random thing I forgot. Okay. Yep. Attempt to index local let 1 a number value in 19. So, oh, I see. It kind of uses a tuple notation. All right. So that's a failure because we don't have, we do not have a glider appearing on screen here. But we can debug things a little bit here. Once I get it drawing the glider, I am going to clock out for this stream. So this I don't even want it to be doing. Okay. Oh, well here's their problem. All right, we're getting somewhere. Right. So instead of ISO to screen, giving you coordinates assuming that you're doing 1 pixel at a time. It needs to do coordinates assuming you're doing 1 tile at a time. So this is 16 right here. So 1 step of X goes 16 horizontally. All right, so 16, and we'll just multiply them both by 16. That will work. Oh, I think we're starting to get it. So let's just do this. Say by some horizontal amount, 80. Boom. There's our glider. We have a glider on screen, folks. Very wonderful. And with that, I'm going to close out my stream. So thanks for watching or rewatching, and I'll see you next time. Bye-bye.